Good morning, everybody. Hopefully you can all hear me. Fingers crossed. So welcome to another webcast from the guys at Innova Systems. Today we're going to concentrate on taking a look at some more SolidWorks in your industry, and we're going to focus today on conveyors. So as you know, we're a reseller for SolidWorks with excellent ratings for customer satisfaction. So that's why we run these webcasts, to help you guys learn a little bit more about how to use the software. So we'll take a look at SolidWorks now, and you can see on the screen here that I've got a sort of large, well, smallish packaging layout plan that's been designed in SolidWorks. So all the components have been detailed in SolidWorks. This can be from the conveyors to the robot to the boxes, the forklift, that kind of thing. And you can see we can get a really good representation of an arrangement here, showing some of the walk areas, some of the keep out areas, things like that. What we're actually going to focus on today is a small area of this, so we're going to take a look at how we can build one of these conveyors up, and I'll show you some nice bits of functionality within that as well. And then towards the end, what I'd like to do is just run through some motion solutions with SolidWorks and Rockwell Automation, just so you can see how we can help size motors and things like that. So that being said, we'll get started straight away and we'll create a new part in SolidWorks. So SolidWorks, as we know, is a very intuitive system. There's plenty that can be done within here, and there's numerous ways to do things as well. What I'm going to do first and foremost is start with a sketch on the top plane, and what I want to do is roughly draw out the overall size that I would like my conveyor to be. So I'm going to start by drawing a rectangle and placing some dimensions on here. So I want this to be 3 meters long, and I want it to be 490 wide, like so, and that gives me the basis for the footprint of the conveyor that I'm going to create. I'm not going to use that aside from to position other elements of sketches. As I said previously, there is numerous ways to do these things in SolidWorks. This is one way. It may not be your preferred method, but it is quite an effective way to draw these things. The next thing I'm going to do is I'm going to create a skeleton of the framework that I want to produce. So when I say skeleton, I mean sketch lines that I'm going to position pieces of steel along. So here I'm just going to draw a line up first and foremost. Now I'm in a 3D sketch now, so you can see at the end of my mouse it says XY, which means I'm sketching in the XY plane. So that's vertically upwards as we look at the screen. So I'm going to start with another line here as well. I'm going to just find the midpoint here of that line and hit the tab key, because I want to sketch in the YZ plane here to join across to that one there. Now that line isn't what we would describe as horizontal, so if I want to make it horizontal, we can say that it's along the Z axis. So you can just select the sketch and say along Z, and that now we can see that we can drag and adjust about as we see fit. I'm going to draw another line in. Again, this time I want to hit the tab key to change the plane, and I want to be on the XY again. I'm just going to place that in space, and I'm going to tell the software that that line sits on that point and make it coincident, like so, and then I can drag that over like so, and just apply a dimension between those two and say that that's 100, and we're going to make it 200 high. And you can see now that my sketch starts to look a little bit more like a conveyor frame. So we'll just draw another line out and we'll do the same over the other side. So we'll just make that coincident, drag that out like so, give that a 100 dimension here, and we've got our back end of the conveyor drawn out. Okay, so if we look over on the other end, we want exactly the same. So again, we're going to start by drawing a line upwards here and here, and what you can see is that I'm just using the points of the 2D sketch that I originally created to position the uprights that I'm drawing. So I'm going to go from midpoint to midpoint, and again we'll just need to set that to be along Z just to ensure that it's horizontal. And now what I can do is say that this point touches this line, which is the coincident relationship, and again just finish that line off by giving it a 100mm dimension there. So now the height at both ends is controlled by the 200mm dimension there, and we can run that one across like so, and again just give that a 100 dimension. So we've got our rough sort of framework or skeleton sketch as I described it at the start drawn out. So we can exit that sketch now and we can take a look at some of the things that we can do. So over on our tree we've actually got two sketches visible. We don't need the original one to be visible anymore, so we can just hide that one and we get left with what we want to focus on, which is building that frame up. Now in SolidWorks there's a really nice piece of functionality called weldments, which we're going to leverage today. So in the weldments set of tools here, the first thing that we need to do is define the part as a weldment. So we're going to tell the software that we want to use this functionality. So all we need to do is click that little button and it will apply an icon at the top of the tree here called weldment. And that just alerts the system to turn on certain pieces of functionality that we want to use. The next thing I want to do is I want to add a structural member feature onto those lines. And all the system does in the background is it sweeps what we call predefined profiles along the paths that we've created. So we've created those paths with our 3D sketch. So now all we need to do is go into the system and choose which profiles we want to use. Now these profiles can be custom for you guys, so you may be using Rexworth profiles, varying different types of aluminium extrusion, or you may be using standard structural steels. Now you can see on my sort of drop down list here I've got a number of different standards that I can choose from. So for example BSI, we could go into an RSC channel and select varying sizes of RSC channel, or RHS, things like that. Today we're going to go into the ISO folder and we're going to use a rectangular tube for the top rails, and we're going to choose 70 by 40 by 5. As I said, these are fully customizable, so you can add any additional sizes that you use that aren't in the default libraries. It's a very, very simple process to do that. We'll choose this one now. So once that's selected, really all we need to do now is just follow the instructions in this yellow box here, which says to select the sketch segments to define the path. So I'm going to choose the top rail and the top rail there. And what you can see is that the system places that profile centrally located on that line. Now we have a number of controls within the structural member property box here. So we could set the angle to 75 degrees, for example. Or alternatively, we could use the locate profile button, which will allow us to position this in different locations related to points that exist on the sketch. So you can see here there's numerous points we can use to position it. We're actually going to leave it in its default orientation, centrally located, and I'm going to add that structural member on. So what you'll see now is we get those two lengths of beam shown on the screen for us. Now what I'd like to do is just draw out the sort of supporting frame for this. So again I'm going to use the structural member tool, except this time I'm going to use a square tube and we're going to use a 40 by 40 by 4. Okay, so just select the different size. Again we can click on the lines to position these items like so. When you have sketch lines in the same plane, the system will allow you to keep those in one group. Okay, so we have a group defined here automatically for us, and we have these two vertical lines. Because these two are in the same orientation, even though they're disconnected, I can select those as well. What I'm not allowed to do is select this connected line because it's in a different orientation. So to do that I would need to add a new group. So I can then specify a new group, pick that line, and I can pick this line as well. What that means is we've got flexibility over which areas of the sketch we can choose and which ones we can't. And what you'll see here is highlighting the difference between using a group and not using a group. So at the top I've created my structural member with a different size profile. Okay, We have to use separate features if we're using different size profiles, but let's say we were using the same profile and we still use two features. We get this discrepancy where the structural member doesn't automatically trim itself to another one, whereas here between two groups you'll see there is an automatic trimming even though the line extends past it to the center point. So when you're using the same profile all the time, it's much better to use groups rather than individual features, because it will give you automatic trimming tools. That being said, we can still use a manual trim tool shown here to actually trim situations like this so there's no intersection. So I can select that, this and this to say that they're what I want to trim, and I want to trim those flat up to the underside face here, like so. Now if you choose a face, it will cut it to that face, but if you choose a body and specify this body and this body, for example, you get a couple of choices as to how it trims. So here you'll see it's still trimming flat. There's no sort of rounding of that profile to match the tangent here, but we can actually specify that we do a coped cut between the bodies, like so. So that can give us a better a more accurate representation of what we would like. We're going to stick with a flat cut, so we'll just accept that like so. Okay, so we end up with our sort of basic framework drawn out. Now what I'd also like to do next is to add in some additional elements of support underneath this conveyor. I'm just going to hide the main sketch for the moment. We can do that using a tool on the standard features toolbar called linear pattern. So for a linear pattern, we just need to specify an edge, define a distance, so it's going to be 500 mil, and define a number that we want, so let's say 5 for the time being. And then what we need to do is specify what we want to pattern. So I want to pattern that item, and that item, and you can start to see visually how they fit on the screen, like so as well. So you can get your calculator and work these values out, but what I'm going to do is just fill in these nominal values for the time being, accept the tool, and then what we're going to do is we're going to build in some intelligence into our framework. So when you're applying intelligence to things in SolidWorks, it can make life easier if you name dimensions. So here we've got our 3 meter dimension, which is currently called D1 at sketch 1. You can see that when I hover over it. If I double click on that dimension, just at the top of this box, I get the ability to rename this dimension. So I'm going to call this length. Okay, that's as much as we need to do at this stage. So now we have a dimension called length. Okay, within this pattern here, if we just select that pattern, we can see that we've got the 500 mil dimension controlling it, like so. And if we double click on that, we should get the number of instances that we're using as well. So here I can say to this 500 mil dimension that I want that to be a little bit more intelligent than just filling in a value. So what we're going to do here, we're going to just use the equals button on our keyboard, which tells the software we want to use an equation, and I'm going to tell this dimension that it needs to be equal to the 3 meters, so that's length at sketch 1, divided by, and that wants to be divided by the instance number, which should be just there, look, the instance number of that pattern. Okay, so if we click the green tick, it's going to divide the 3 meters by 6 to give us the value of 500. Okay, so that's automatic now. What we're then going to do is configure the instance number to equal, again, the length divided by the actual distance between here, which will give us a value of 6. So both those values are equations now, and we can view those equations by going to the equations box here and managing those. So they show up here like so. Now we have created a circular reference, but we're not going to worry about that too much at the moment. What I want to show you is that we can now grab hold of this dimension here, so we could change it to 2100 for example, and if we rebuild the model we get a number of different spaces between those items like so. So we can start to adjust on the fly this dimension to equal any value that we want, and we should have the correct number of instances and the correct number of spacing between them. What you can also do with these as well is be a little bit more intelligent about the equations and actually build in if statements into that as well. So if you want a particular spacing all the time, but if it goes over that spacing you need to add in an extra one, you can create if statements to control those type of things. Okay, so we've got our sort of basic framework drawn out. One thing that's worth pointing out here as well is just on the bottom, ideally what we would like is to cap these structural members off with a piece of plate so we can screw a foot into them. So what I can do here is use on the weldments toolbar something called the end cap tool, and that will allow me to select the end face of a structural member like so. So we can grab hold of these two ends here. You can actually use the G key on your keyboard if you don't want to zoom in and grab hold of those items like so. Then what we could do is grab hold of the base feet here. I'm not going to select all these ones in the middle because I'm going to show you something else in a moment, and I'm going to grab these two end bits here like so. Now within the end cap tool we have control over the position of those end caps, so whether they're going outside, so adding length to that structural member, or whether they're going inside, so removing length from that. We can alter the thickness. We can also use a thickness ratio, which is the offset distance between the edge, or we can change that to 0 and it will completely cover the end. Here if we chamfer the corners, we might want to just increase that to 5, well, say 7 there, just to cut back from that fillet there. We can do things like that quite easily. So if we add those on, you'll see it trims those members down. Now really what I should have done is done the end cap feature before the pattern, because then what I could have done is included these little end caps when I patterned all these items here. Now we all know hindsight is a wonderful thing, but the really nice thing about SolidWorks is that we have the flexibility to make changes like that if we want to. So even though I've done this end cap feature after the pattern, I can grab it and move it before the pattern. Okay, what that means now is that I can edit the pattern feature and select the end caps like so. And what that will do is it will include those now in my pattern. So I haven't had to go through and accept all those extra bits and pieces. Now just to show you an extra level of flexibility that we have within the system as well, at any point in time you can take the bar at the bottom and roll it back to a particular section. So here for example I could roll back to just after I created the end cap feature and add in a hole into that end cap. So here I'm going to choose a plain hole. I want a 10mm plain hole, and I want to position that on this face here, here, and we'll do the other two at this end as well, like so. And just to be a little bit more accurate, what I'm going to do is sketch out a line between there and there just to give me a center, so I can drop that point on the center. We'll do the same down here as well, and then we'll finish off the two at the other end. We could have created this positional sketch beforehand, but you can also do it within the feature like I have here. So we've now added that hole in. Because we've added that hole in to the end cap and then we patterned the body, that hole is now included in each of the pattern bodies that we've got over here as well. Okay, so the next thing I want to do is just create a hole in this side frame here just to take the rollers. So I'm just going to start a very simple sketch, draw out a center line just to ensure it's in the center, like so. Place a circle on that, which is what I want to cut, and that's going to be 15 mil, and it's going to be 30 mil away from the end. Now I've got a slotted roller that I want to put in here, so I'm just going to put another rectangle inside that circle and give that a length of 9 there. So now I'm going to use this sketch to create my cut. So if I use my extruded cut tool, the system doesn't know which area we want to cut out at the moment because we've got this crossing area. So I actually want to remove here, here and here, like so. So we can just manually pick those on the screen. Now I'm going to specify that to be a 5 mil depth in that direction, but I also want to go in direction 2 as well, and I want that to be offset from this face. Okay, so at the moment it's offset 10 mil in this direction, but I can reverse that and say go inside the same 5 millimeters. Now we're just going to make sure that we select the two bodies we want to cut, which are these two here. Click the green tick and we can end up with our cut feature in both of those bodies. Okay, so what we can do now is we could do another linear pattern along this edge here. I know my spacing needs to be 80 mil for how I want to space my rollers, but I'm not sure of my quantity just yet. And then I can select that whole feature to pattern like so, and you'll see we end up with that 6 running along there like so, which is exactly what we want. Okay, but we're going to build again some intelligence into that pattern feature for the quantity. So we've got a 6 value there that we want to grab hold of. It's a bit small. You can actually get to that in a slightly different way. So if you find it awkward to select from the graphics area, it's just something I'm used to, but they did actually bring in the ability to be able to create those equations in the property manager on the left hand side now as well. So here I can just change that to equal the length, which we know is in sketch 1. So we'll just grab hold of sketch 1. We might not be able to grab it in here, but we know that to be length at sketch 1, so you can type this in like so, but that does need to be in speech marks. So if we grab hold of that there, it'll go blue if it knows what it is. Now interestingly enough, this hole starts from the end of this long member on the top, which is actually 200 mil longer than the length we defined at the start. So I can add on the 200 into my equation here and just include that in brackets. So that's going to give us 3,200 in its current organisation, and then we're going to divide that by the pattern distance, which is 80 millimeters. So we can fill in 80 there if we want to, like so, and that gives us our equation, which is now going to work out, based on the length, the number of holes that we want along that structural member. So again, just building in some level of flexibility so that when we do come to alter this conveyor or make a different size, that the intelligence that we've captured remains in that and we don't have to change a huge amount of things. So that's pretty much our basic frame created. So the next stage for us would be to produce an assembly and start adding the feet in and the rollers and things like that. But we're going to pause at this point, and I'm just going to save my model. So we'll save this away. We'll just save it on the desktop, and we'll call it frame. Okay, and I want to show you another couple of bits and pieces now. So the first thing is, because we've been working with the weldments functionality, what the system actually does for us is it creates a cutting list. So over here on the left hand side in the feature manager we have a cutting list, and if we click the plus on this we can see that we've got a total of 41 items within this cutting list. Now at the moment there's no intelligence to how it's organised these, it's just a list. But if we want to apply some intelligence to that, we can just right click on here and say update. And what the system will do is it will categorise all those items into the same profile size and length and organise them so we can see which bits are what. Now this is really quite useful, and if we take a look at what it does, it actually creates this cut list table. So we can see here that we have specific item numbers, quantities. The description is actually the information pulled from the weldment profile we use, so it's profile size, and then we've got length over here as well. Now what we don't have here are two blank entries there for the end caps, but we can actually get the system to generate some information for those as well. So if we right click on here and use the create bounding box functionality, anything that you've created in a weldment part using a standard extrude or some sketches that you've done yourself, we can use that create bounding box, and that will then give us the information within the cut list table. So we can see now that we've got these items of plate 5mm thick, 40 by 70, and here we've got 40 by 40. So it categorises that information for us automatically. So some really useful functionality there. So let's take a look at this in action in a drawing. So if we create a drawing here, we'll just choose a paper size, and we've got our drawing on the screen. Over on the right hand side here we can choose any of the views that we want to use in our model. So if we want an isometric, for example, up the top there, we can place that down. And if that's not in the best orientation, I can just move that around, save it, we'll call that Ed, and say OK, and we've now got a view that fits on the page better. At any point we can go back over to here and say, well, now I want to have the top here, front there, and we could then project a view off here like so. So just some standard functionality to generate those views. The really nice thing about weldments as a functionality, as we've just seen, is the generation of the cut list. So we can include that on our drawing as well. We can tell the system to insert a cut list and place that down on our sheet. So it effectively becomes a bill of materials for a frame. Now the good thing is here that it's got the item numbers categorized, so we can come over to the isometric view here and automatically balloon that if we want to, and keep all the balloons at the top, for example, like so. And we'll just resize that line a little bit so we can identify which member is what on that drawing very easily. So some really useful functionality that we can leverage there within drawings. Obviously we can bring through all the dimensions as well. We can place additional ones on if we want to, so we can just access these views, use the dimensions in the normal way. Or alternatively you can actually use something called model items. So here we could go into model items and say we want to bring in the entire model dimensions. We want to specify that in all views, click the green tick, and we'll end up with a number of dimensions on the page here, what we should do in a moment. Using the model items functionality, we may get some dimensions that we don't want. So here we've got some of the thicknesses of the end caps, bits and pieces like that, and we may also end up with some of the weldment profile sizes. But it gives you a good sort of number that you can play around with, reposition as you see fit. Any of these we can delete at any point as well, so we don't have to keep these. We can just organise them how we want to. Okay, if we switch back over to our frame part, so as I said, the next sort of logical stage for us is to create an assembly from this. So we can go up to our top menu, make an assembly from this part, choose an assembly template and place that down into our assembly. Now I've got a few other bits and pieces drawn out, so I'm going to insert those components from where I've saved them, which hopefully I can remember. Fingers crossed. Here we go. So I've got a roller assembly here that I want to insert in. So I'm just going to open that up and place it into my assembly. Whenever we place anything into an assembly, it can move around, rotate around like so. We need to define its position in the assembly. So we should have a matching notch in our slot here. So what I'm going to do is select the cylindrical face and use a mate to position that in here like so. So that is now concentrically aligned to that hole, so we can see the component can rotate. But what we want to do really is position that in between these two pieces of framework. To do that we can use a mate called width. So I can specify this face and this face and also this face and this face, and what the system will do is equate that so that the component actually fits in the middle. Now at the moment that can still spin like so. So what I really want to do is just grab hold of one of those flat faces and make that parallel with another flat face like so, so it's positioned accurately. Now we've positioned that roller, it can't rotate. The system tells us it's fully defined and it cannot be moved, but really we want to show some movement in that roller. So what we need to do is make that sub-assembly flexible. So we'll do that, and then you can see now the roller will actually twist on its axis. That's the movement that we sort of expect from a roller. These lines have just been put on so you can see that there is actually movement on that component. Once we've got our roller, we could go through and position all the rest of them in there, but I think there's about 40, so it would take us a little while. One of the things that we can do in SolidWorks to help us is actually use what we call a pattern-driven component pattern. So we can tell the system what we want to pattern, which is this assembly, and we can tell it a pattern that we want to copy the information from. So here this whole pattern is at the same spacing, so we can select that, and it will now create all of those along our conveyor very quickly. Now the really nice thing about using these sorts of functionalities is that if we do change the length of the frame, the number of holes changes, so that would mean the number of rollers change as well. So all the while we're building in this flexibility into what we're doing. So we'll go ahead and we'll put in our foot component now, which we've got here. So we can place that into our assembly like so, and I'm just going to make that into position like so, and we'll just move that and just attach that edge to there like so. Okay, so that's our foot in. We'll just drag another instance in and do it towards the bottom here as well. Just make those two edges together. So we can also leverage that pattern-driven pattern here as well. So we can specify we want a pattern-driven pattern, we want to pattern these feet, and we want to use this pattern to do it, like so. So we end up with all our feet in. Now the two end feet don't populate because we actually didn't create these as a pattern here. So one of the other functional or pieces of functionality that we have to quickly position things is something called copy with mates. We can select a component, it will read the mates that we've created on that, so the concentric and the coincident, and it will allow us to repeat those very quickly. So here I can select that cylindrical edge, that face, like so, and we can right click and it will allow us to do another one. So cylindrical face, another face for the coincident mate, right click to accept, and we've positioned all our feet in our assembly very quickly. So we've now got our sort of framework almost complete. One of the other things I wanted to highlight here as well is we also have the ability to insert what we would describe as an assembly feature, things like belt and chain. So if you were putting a belt over the top of these rollers, we probably wouldn't in this situation, but here you can select what is contributing to the belt. So these two items here. It will show us a preview of the belt and also give us an indication of how long that is as well. So if you are sizing belts for conveyors and things like that, this piece of functionality is very useful. It will also engage for motion as well. So if you do want to show motion in items, you can see here, if we twist that roller, we might just need to zoom out a little bit here, but if we grab that roller and turn it, you'll see the back end roller turns as well. So we've got a driving belt that is actually helping us to move the other end as well. Okay, one of the other things I wanted to talk about is what we can use the intelligence we've created in the components for. So here we've got our framework drawn out. Those of you who've used SolidWorks before may be aware of something called configurations. We can now use the intelligence we've created and this dimension to create numerous versions of our framework. So we do this using the configure dimension tool. So we could, for example, create a new configuration at 2000 long, and the system allows us to fill in some dimensional information for that length. We could say we want 3000 here, so we'll just fill in that value, and maybe we want a 1500 as well. Okay, and this could be any number of conveyors separated out by any number of sizes. It's entirely up to you what you do. You just fill in the numbers here, give them some names, that could be your internal part numbers, and say OK. And what the system will do is it will actually generate us those configurations here. So if we took a look at the 1500, for example, it tells us a message about the bounding boxes, but we can see there that we've updated that information. We may need to do a bit of work with the support structure underneath in terms of dropping off some items, but you can see that the holes update quite nicely, and we end up with a number of different variants of that conveyor. Now once those configurations are created, that in itself is useful, but if we go back to our assembly, we can create the same configurations here as well. Okay, so we've got a 1500, a 2000 and a 3000. We'll just remove the belt functionality because that will struggle a little bit. And what we'll do is we'll just take a look here at which configuration that one's using. So we want it to use 3000 in here. And we can add the same configurations in here. So we can add a configuration 1500. We'll add 2000. And we'll add 3500. Now what we can do is configure which component is displaying in which configuration. So here if we specify the configurations, hold on, well we can do it a slightly different way. We'll activate one of the configurations here, the 1500 one, and we can drop this down to 1500 for this configuration. Like so, you'll see the information for the number of rollers updates. We'll activate the 2000 configuration, and again specify which framework is displaying here. So that's 2000. Again, you see that pattern information updates, and if we do the 3500, just to finish off, we want that to be the default one. We haven't named that one. We end up with our updated information for that assembly as well. So creating these variants with intelligence is a really quick way to get lots and lots of variety within your product ranges. Now if we save this assembly on the desktop, what we can do, obviously when we've created our assembly, is we can position that in a higher level assembly. So if we went back to what we were looking at originally, we can insert our assembly into here and then position it relative to our other conveyors. So here if we just use our make tool, we can say that we want the base of that component to touch the floor, like so. And then move it back into a more appropriate position, and position it relative to other items. And we can start to build up our layout of conveyors, as we have here. So maybe we could say that that face and that face were coincident, so mated together, and we positioned that face and that face together, like so. So we start to build up our arrangement of conveyors to design our system. Now one of the things that I want to finish off with is some of the sort of added functionality you get with a system like SolidWorks. So we spoke about motion right at the start. That can be included. We've sort of run out a little bit out of time to show you the motion section. So what we'll do is we'll do that as a separate webcast in the future. But what I do want to finish off with is to show you a quick video just to highlight some of the functionality that we can give you over and above designing componentry in SolidWorks. So this video is all created in SolidWorks using the SolidWorks Motion Manager, so we can create these types of motion. And then it's actually been rendered in the SolidWorks renderer as well, so something we call PhotoView 360. So you can see we can get some really nice effects from these systems, once you've designed all your components and put your systems together. Okay, so that sort of takes us to the end of this webcast. Thank you again for watching. We do have a couple of other ones coming up in the future as well. So we've got one next week on machine design, and then on the 6th of February we're going to take a look at lighting design. And if you keep an eye on our website, you'll see what the future ones are going to be as well. So thanks again for watching, and we'll look out for you the next time. Thanks very much.